Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is minimal score after removals on a tree. Now, the problem category is of hard level, and I would say yes, the problem is a bit complex, but after watching this video, after understanding the problem and the solution approach, you will be able to solve this problem along with understanding it as well. Now, the given input in the problem is an integer array, and let us call it as nums. And there is another input which is a two-dimensional array, and let us call it as edges. So we are basically given a graph, and the question is calling this graph as a tree. So let us consider this as a tree only. The tree is having nodes, and these nodes are given in the integer array nums, and the tree is connected via edges, and this edges is given in the 2D array edges. We need to find the output as the minimum possible score. Now it is important to understand how can we find the score, but our goal is, if we understand how to find the score, we need to find that score which is minimum possible for the given set of input. Now how to find a score? So basically initially we have a undirected connected tree. We have a tree which is connected, that is all the nodes of the tree is connected, right? And it is undirected. When we say undirected, it means that if two nodes are connected, we can go from this node to this one and from this node to this one as well. There is no certain direction. There are total n nodes given, which is actually given in the input array nums. The number of input in the array nums is equal to the number of nodes we are having. That is, each element in this array nums is denoting one particular node. So we have total n number of nodes, and to create a graph or to create a tree of n nodes which are all connected with each other, because we have a connected tree. So if we have n nodes, we need at least n minus 1 edges. And that is because, let us say we have two nodes, 1 and 2, then we are going to need one edge to connect it. If we have three nodes, then we are going to have one more edge. If we have four nodes, then we are going to have one more edge. So we are having 1, 2, 3, 4 nodes, and we are having 1, 2, 3 edges. So that's the straightforward formula. We are having n nodes, and we are having n minus 1 number of edges given in the two-dimensional array edges. Basically, this particular 2D array is having each element as another array of two elements, and these two elements are nothing but two nodes, which is telling me that these two nodes are connected by edge. So what we have is, we initially have an undirected connected tree of n nodes and n minus 1 edges. What we have to do is, we have to remove any two edges from the undirected connected tree. For example, if we have a tree, 4 nodes, and they are connected with each other, if we remove this node and this node, that is, we remove two different nodes, then we are going to have 3 undirected connected tree. This is the first one, this is the second one, and this is the third one. Basically, if you have undirected connected tree with n minus 1 edges, and if you remove any two distinct edges, now you will have 3 number of undirected connected tree. After removing the two edges, we have 3 undirected connected tree. Now to find the score, we need to find the XOR of all the values in the 3 trees. That is, we have 3 undirected connected trees. In all these 3 trees, whatever are the elements, for each element, you need to find the XOR value. So you will have a total 3 XOR values, right? So let us say there is a tree, right? And to find the XOR value of this tree, you need to find the XOR of this, this, and this, and this. If the elements are, let us say, 2, 4, 5, and 3, then the XOR value will be 2, XOR 4, XOR 5, XOR 3, right? So you have to find the XOR value of all the trees, all the 3 trees. That is, find the XOR of all values in the 3 trees, and let us say the values are F, S, T for the first tree, second tree, and third tree. Now the score is equal to the maximum value of all the XORs we have minus the minimum value of all the XORs we have. That is, the score is going to be the difference of maximum of all the 3 XORs and the minimum of all the 3 XORs. We just need to minimize this difference. That is, we need to minimize the score. So we have to remove the two edges in a smart way, such that the 3 connected trees which are created are having some XOR values, and the maximum and minimum of these values have some difference. That difference is your score, should be minimized. So let me show you one example of this. Let us say your nodes are 1, 5, 5, 4, 11. This is your integer array nums. So we have 5 elements or 5 nodes, and the nodes are having indexes, we can say as 0, 1, 2, 3, 4. So these edges are actually given as indexes. It means that if it is 0, 1, it means the node at index 0 and the node at index 1 are connected with each other using edge or with a edge. That is, 1 and 5 are connected with each other with a edge. So we have total 4 number of edges, in which the index number 0 and index number 1 are connected, 1 and 2 are connected, 1 and 3 are connected, and 3 and 4 are connected with each other. How this is going to look like? It will look something like this. The nodes are 1 at index 0, 5 at index 1, 5 at index 2, 4 at index 3, 11 at index 4. The edges are 0, 1. It means 1 and 5 are connected. We have this node 1, and then it is connected with this node 5, right? This is the edge. Then we have 1, 2. It means the node number 1 and node number 2, that is 5 and 5 are connected with each other, right? Now we have 1, 3. It means the node number 5 and node number 4, they are connected. So this is the node number 1, which is connected with node number 3. This is the edge. And now we have the edge from 3 to 4, which is node 4 and node 11. So we have node 4 and node 11 connected with each other. So the tree looks something like this. Now we need to divide this tree into 3 connected trees, right? For this, we are going to delete 2 edges from the tree. So first of all, I'll tell you the answer for this particular problem. Later on, we are going to understand the intuition behind this and how we can find the output. But first of all, in this case, the 2 edges which we are going to remove are this one and this one. So after you have removed two edges, basically the edge 0, 1, this one, and the edge 1, 2, which is this one. Once you have removed this particular edge, now what you have is you have one tree which is having just one node, another tree with one node, and another tree with three nodes, right? Let us say that this is our first tree. It has just one node, so the XOR of this will be 1. We have this tree, it has one node, and its XOR will be 5. And now we have another tree with three elements, 5, 4, and 11. So the XOR of this particular tree is going to be 5 XOR 4 XOR 11, which is going to be equal to 10, right? So the difference between the maximum value of all these three values will be 10 minus 1, because 10 is the maximum and 1 is the minimum. So the difference between the max and min is nothing but 10 minus 1, which is 9. And that is going to be the output for this particular input, which is given in this particular problem. This is basically the example number 1, which is already given in the problem. Now let me explain you how can you think about finding the solution. This is our tree, right? First of all, let us store some values which are already given to us. Let us store the value of n, which is equal to the number of nodes we are having. We are having as of now 5 nodes, right? If we have 5 nodes, then we are going to have 4 edges, right? It means n minus 1 edges. Now in the start of this video, I have told you that although they have said that this is a tree, but in reality this is like a graph, right? There are nodes which are connected with each other. You have this node which is connected with multiple edges, right? So we can say that this is like a graph. So let us store this graph somewhere, right? And this graph is basically undirected. It means if I'm talking about this particular node, if it is connected with 1, so I can go from 5 to 1, I can go from 1 to 5 as well, right? We can go in both the directions, so that is why it is an undirected graph. We have 5 nodes, right? The nodes are 1, then 5, then we have one more 5, then we have a 4, and then we have 11, right? 1 is connected with 5, right? This 5 is connected with 4 and 5 and 1. So 5 is connected with 4, 5 and 1. This particular 5 is only connected with this 5. We have this 5 here. And then this 4 is connected with 11 and 5. We have 11 and 5 here. And now we have this 11 connected with just 4, right? As of now, I have not done anything out of the box. I am just storing my graph, or basically the tree, in a adjacency list. That is, for each node, I am creating a list with which my node is connected with, right? Now the next thing is, how can we solve this particular problem? How can we think about solving this problem? So first of all, you need to understand that in this problem, we have to find the XOR of 3 different trees, right? And those trees are actually going to come from my original tree. We are going to remove some edges, and then we are going to have 1, 2, and 3 trees, right? Now before this, you will have to understand about few properties of XOR, how this XOR works. See, the thing is, the most important thing which you need to understand is, if you have just one number, then the XOR of just one number is the number itself. That's the first thing. Secondly, if you take the XOR of 1 with 1, this is going to be 0. That's the second thing you need to understand. This is the property. This is the mathematical property. If you're saying 1 XOR 2, so this part is 0, right? So you can say it is 0 XOR 2. And 0 XOR 2 will be nothing but 2 itself. That is, if I'm saying 1 XOR 2, they are going to cancel it out, and this will be equal to 2. Or let us say I'm trying to find out the XOR of 1, 5, 5, 4, 11. XOR of all these values, maybe XOR of all these values, let us say x. Now, if I take the XOR of x and 1, that is x XOR 1, and let us say this is equal to y, in this case, what will happen? What we are actually saying is, this y will be the XOR of 5, 5, 4, 11. And I will tell you how. And let us say the numbers are 1, 5, 5, 4, 11. If you take the XOR of all these values and get the value of as x, and now you are saying that x XOR 1, it is like saying, in this particular XOR list, you are also adding one more 1. That is, if this XOR is x, and then you are saying x XOR 1, it means 1 XOR this particular value. And it is like saying you are going to cancel 1 and 1. So 5 XOR 5, XOR 4, XOR 11. So you have to remember all these formulas, all these techniques which XOR has, and these are nothing but basic mathematics. Now, if I ask you one thing, that what is the XOR of this whole tree? This is 1 XOR 5, XOR 4, XOR 5, XOR 11, right? Now the question says that you have to remove 2 edges. Now let us say we have to remove one edge. Let us try to understand what is going to happen to the XOR value when we are removing one edge. Let us say if I remove this particular edge. So now we have 2 trees, right? We have a tree here and we have a tree here, right? If I can find the XOR value of all my values, right? It is 1, 5, 4, 11, 5, XOR of all my values, and I can store it somewhere. But now, if I just remove one edge, I have 2 trees, 1 and 2. In this case, if I will ask you, can you find the XOR of the first tree and can you find the XOR of the second tree? Then what you can do is you can say, okay, let me go through all the elements of this tree and let me go through all the elements of this tree. Then you can say, okay, the first tree is having the XOR value as 1. The second tree will have the XOR value of 5, XOR 5, XOR 4, XOR 11, right? And now this is one process of finding the XOR of 2 trees. But the question says that you have to remove 2 edges. Now, if I remove one more edge, which is this one, and I ask you find the XOR of all my 3 trees, you will say, okay, this is my first tree, this is my second tree, this is my third tree. The first tree, the XOR will be 5, the second tree XOR will be 1, the third tree XOR will be 5, XOR 4, XOR 11, which is actually equal to 10. So what you are actually doing is, you are removing 2 edges, right? And then you are trying to find out the XOR of the whole tree. Now, since we do not know that we have to remove this and this edge only, as of now we know the answer, but try to think about the intuition. Initially we don't know the answer, right? So how do we know that we have to remove these 2 edges? The thing is, we do not know, right? So what we can do is we can actually try to remove all the different pair of edges we can remove. Since we need to remove two edges, so I can say, okay, let me remove this and this, or let me remove this or this, or I can say, let me remove this and this, or maybe I can say, let me remove this and this, or maybe I can say, let me remove this and this, or maybe I can say, let me remove this and this. Basically, trying out all the pair of edges we can remove. For example, if I remove this edge and this edge, I will have one subtree here, and another subtree here. Three number of connected trees, or I can say three subtrees from my original tree. Now I will have to find the XOR of all my three trees, and then I can check that which particular edges pair is giving me the minimum score. Basically, to find the score, what you will do, you will find the maximum of all the three XORs and the minimum of all the three XORs, and you will say max minus min. This is the score. We need to minimize the score, right? Now the thing is, you cannot avoid the scenario of checking for all the edges, right? You have to check for all the edges, and you have to find the XOR of all the trees which are getting created after removing the edges. But the problem is, if you remove two edges, and now you try to find the XOR of this, this, and this, and then you find out that you removing these two edges is giving you some value x as the score. But if you remove these two edges, you are getting a value y, which is less than x. So y is a better answer, right? Y is a better score. But you have to go through all the different trees which are getting created after removing the edges. Now here is the problem. If you try to find the XOR values of all the trees, it is going to give you the time limit exceeded error, because it is a complete brute force algorithm. You are not using any kind of optimization, so it is a complete brute force. Now one of the way we can solve this problem is, if we know about the XOR of all my values, try to think about this. And I told you that this is the XOR property, that if I know the XOR of all these 5 values, and then if I say that, okay, find the XOR of this value and XOR of 11, then this is like saying that I'm eliminating 11 from here, and I'm trying to find out the XOR of 1, 5, 5, and 4. How is this going to help us? How is this particular formula going to help us? See, the thing is, if we are removing one edge, then what we are actually doing is we are saying that I am now disconnecting this particular node with its parent. This is what I am doing. This is what's happening. If I'm removing this edge, it is disconnecting this node with its parent. I know that as of now the tree is undirected. Undirected means that we do not have any parent or child, right? We can move from here to here or here to here. But since it is like a tree, that's what they have mentioned in the question. In a tree, we have a parent node, and then we have a child node. If we try to think about this parent-child relation, so let us consider the node 0 as the parent of node 1. Let us just consider this. And why I am saying this, the reason is 1 XOR 5 is actually equal to 5 XOR 1, right? So we know that this is, if we assume 1 as the parent or 5 as the parent, it is not going to harm. Both are fine. Both will be fine, because we have to execute the XOR operation. So let us assume the lower node number as the parent. So 1 is the parent of 5. 5 is the parent of 5 and 4. Basically the node 2 and node 3 is having the parent as node 1. Alright. And the node 4 parent is node 3, because we have 3 and 4 connected. Now how is this going to help us? The thing is, if we know the XOR values of my whole tree, and now if I remove one edge, let us say I remove this edge, it is like saying I am disconnecting this particular node with its parent. And how can you even think about this? See, the thing is, we are not thinking anything out of the box. If we are removing one edge from this node to this node, if we are removing this edge, it is like saying that we are removing the parent of this node, right? Now we have two subtrees. This is a tree and this is a tree, right? Now, if I want to find the XOR of this particular tree, it's simply like saying that from the whole tree, from the whole XOR value we have, I am just removing the value of 1, right? It means if I want to remove this edge, I am saying that this is parent, this is child. So I can see from the total XOR, just do one more XOR of the parent. If you do the XOR with parent, it's like saying that you are eliminating 1 and 1, and now it is 5, 5, 4, 11, which is 5, 5, 4, 11. So we don't need to go through all the elements of my tree. I can directly find the XOR value of this tree, right? That is, if I just remove one edge, if I remove this particular edge, then simply with the whole particular value, whole XOR value we have, take the XOR with the parent. This is my parent, and I can get the XOR of my remaining tree. But how can you get the XOR of this particular tree? Because as of now it is just one node, but let us say we don't remove this edge, we keep this edge, and what we do is we are removing this particular edge. If we are removing this edge, it means I am saying that I am removing the parent from 4, I am disconnecting the parent of node 4 with node 5, right? This is the parent, right? If this is the parent, then if you will apply the same formula, that is, if you are taking the XOR of the whole array with the parent, right, then what you are doing is you are eliminating this 5 and 5, but you are not eliminating 1, you are not eliminating 5. What I mean to say is, if you remove this edge, you have two trees. This is your first tree, this is your second tree. In the second tree, the tree which is having the child, in this tree, you have to find the XOR of 4 and 11. Earlier, when we removed this edge, our thought process was, okay, if I remove this edge, what I'm saying is, this is my subtree. The XOR of this subtree will be, take the XOR of my whole XOR value we have with parent. But this is not true. If I remove this particular edge, now the parent is 5. If I take the XOR of this value with 5, it is going to eliminate 1, 5, but it is not going to eliminate 1 and not going to eliminate 5. It means that you cannot use this formula directly, but this is going to help us. And how is this going to help us? I will tell you. If you try to think in the reverse order, try to think in the reverse way. If I'm removing this particular edge, what I'm saying is I have two trees, 1 and 2. As of now, we have understood that even if we remove one edge, it is not important that the other tree is having just one node, right? because if I remove this particular edge and keep this edge, the other tree is going to have 3 different nodes and 2 edges, right? So we cannot just say that the parent is actually equal to the XOR value. We have to find the XOR value. Now, to find the XOR value of this tree, what I can do is with the total XOR, if you will notice the total XOR, if I start taking the XOR of the total XOR with all the elements of the other tree, that is 5, 5, 4, 11, that is 5, 5, then 4, then 11, then I'm saying that eliminate 11 from here, 4, 5 and 5, and the only thing remain will be 1. So it's like thinking in the reverse order. If I remove this edge with the total XOR value, if I want to find the XOR of this tree, what I can do is with the total XOR value I have 1, 5, 4, 11, 5, I can take the XOR again with 5, 4, 11 and 5, the XOR of this particular tree. So I can find the XOR of this particular tree, and then I can take the XOR of this particular tree with total XOR. So it is going to eliminate all the other values, and I will just be remaining with the XOR of my first tree, right? So at this point, what I understand is whatever subtree is being created, I want to find the XOR of all those subtrees, right? Now I have one subtree, I have two subtree. I know that we have two edges, but just to explain you the idea of thinking, the intuition, I'm right now considering that we have to remove one edge. Later on, we will see how can we remove the two edges, and the same formula is going to apply. See, the thing is, if I can find the XOR of my subtree, which is getting created, that is the tree which is having the child, then I can use this XOR to find the XOR of my one tree, which is this one, and the other tree as well, which is this one, right? This will be applied in all the cases. That is, if I just remove this edge, and now if I try to find the XOR of this value 4 and 11, whatever is the value of this 4 and 11, if I take the XOR of this value and the total XOR value we have, that is XOR 4, XOR 11, it is like saying that eliminate 4, eliminate 11, and we have 1, 5, 5, we have 1, 5, 5 in the other tree. So it is very simple to understand that we need to find the XOR of all the subtrees. If I remove this edge, we have this as the subtree, right? If we remove this edge, we have this as the subtree. If we remove this edge, we have this as the subtree. And if we remove this edge, we have this as the subtree. It means that at every node, we need to find the XOR of all its child and the node itself. Because if I just remove this edge, what I'm doing is I'm creating a subtree, this one. I'm trying to find out the XOR of the parent, which is 5, and its children, 4, 11, and 5. If I'm removing this edge, I am trying to find out the XOR of 4, which is the parent in this particular tree, and the child, which is 11. So what we will do is at each of the node, we are going to find out what is the XOR value of this node and the other child nodes. That is, the XOR value at 1 will be XOR of 1, 5, 4, 11, 5. XOR value of 5 will be 5, 4, 5, 11. The XOR of 5, 4, 5, 11. XOR of this 5 will be 5. XOR of the 4 will be 4 and 11. 4 XOR 11. And XOR of 11 will be 11 itself. For that, what we can do is we can follow a simple DFS, depth first search. We are going to say the XOR at 1 will be 1 XOR whatever is the value at 5. Because the value at 5 will be XOR of 5, 4, 11 and 5. If you take the XOR of this and 1, it will be the XOR value at 1. To find the XOR value of 5, it will be the XOR value of 4, XOR value of 5 and 5 itself. So using a simple depth first search, try to find out the XOR values at each of the nodes, right? So that later on when we are removing one edge, then we can say that the XOR value of this tree will be nothing but the total XOR and XOR of 4, XOR at 4. The XOR value at 4 will be XOR of 4 and 11. Basically the XOR of 4 itself and its childs. So this is what we are trying to achieve. We are going to create a sub XOR value. Basically the sub XOR means the XOR values for each of the subtrees. We have the complete tree as a subtree. Then we have this as a subtree. Then we have this as a subtree, this as a subtree, and this as a subtree itself, right? Now let us remove two edges and try to think that if we have the sub XOR values, can we get the answers quickly? Let us say we remove this particular edge and this particular edge. We have two different edges which are being removed. Now if we want to remove this particular edge and this particular edge, that is 0, 1 and 1, 2, it means that you are saying that with the node 1, the parent 0 is gone. With the node 2, the parent 1 is gone. Now the node 2 doesn't have the parent as 1. Now the node 1 doesn't have the parent as 0. Now we have 3 subtrees, right? These are the 3 subtrees. Now can you find the XOR values of these 3 subtrees? See, the thing is, for this tree, the XOR value is already calculated in the sub XOR, right? We have just one element and its child. Whatever are its child, we have already calculated it in the sub XOR. But for this tree, there is one child which is removed, right? For this particular subtree, we have calculated the sub XOR value, which is for the 5 node, because the childs are 4, 5, 11 and 5 itself. But now it doesn't have this as a child, right? Let us try to solve it in a bit different way. We can say that let me select 2 nodes. We are not going to select 1 because that's the parent of the whole tree. Because if we are selecting 2 nodes, what we are saying that I am going to disconnect with this node with its parent. I am going to disconnect this node with its parent. I am right now removing the same edges, but right now I am trying to solve it in a bit different way. I am saying I am selecting 2 nodes. These are my 2 nodes, right? These are my 2 selected nodes. I have selected these 2 nodes, but selecting means that I am removing the edge with its parent. So we are never going to select the main parent node because it won't have any parent, right? So let us start from the first node and the second node. If we are selecting the first node and the second node and we are saying that let's remove the parents, but let us say that we are selecting the node as 4 and 5. If you select the node as 4 and 5, then what you are saying that I am disconnecting 4 with its parent, disconnecting 5 with its parent. Here you will notice that we have three trees. This is the first tree, this is the second, this is the third. In all these three trees, you will notice that for this tree, we already have the value in the sub XOR table because we have calculated the value for this particular node. For this node, for this particular tree, the XOR value will be 4 and 11, 4 XOR 11, which we have already calculated because in the sub XOR table, we calculated the parent and all its childs XOR. Same goes for this particular tree, right? And for the remaining tree, the XOR is actually going to be the XOR of all my values. And then you take the XOR of this with this particular XOR and this particular XOR. That is the XOR at 4, XOR at 5. That is because these two edges, which are as of now removed, these two edges are not having any relation with each other. And that is why if you remove these two edges for this particular subtree, you don't have to do the calculation. Because for this particular subtree, this 5 is not involved, right? We have just 4 and 11, which we have already calculated in the sub XOR table. And for this particular subtree, we have no involvement of 4 and 11, right? But for this particular subtree, we have the involvement of 4, 11 and 5. But what I can notice here is if I'm removing two edges which are not related with each other, which are independent of each other, then for two subtrees, I can directly calculate. And for the third subtree, what I can do is I can say I just need the value of 1 and 5. So I need to eliminate 5, 4 and 11, right? Just 5, 4 and 11, 5, 4 and 11. So what I can do is for the other subtrees, for the other two subtrees, whatever is the XOR value in the sub XOR table, the sub XOR table for this tree, this particular node is going to have the value. That's the parent. So we have 4 XOR 11. So we are going to remove the XOR value of the first tree. And we are going to remove the XOR value of the second tree. So XOR 4, XOR 11, XOR 5. 5, 4 and 11 is going to be eliminated and we are going to have 1 XOR 5. So we have got one scenario that if we are removing two edges which are not related with each other, then we can directly say that this is the first tree, this is the second tree from the sub XOR table. For the third tree, take the XOR with the total and the other two trees XORs. That's the straightforward solution. But how can we find that these two edges are not related with each other? What we need to understand here is we need to store the list of family members we have for 4 apart from the parent itself. Don't include the parent because in the sub XOR table, for each node, we are considering that node as the parent and the later nodes, the down nodes as the childs. So what we will have is we have to create a family table. So let me create a family table for each of the node. For the node 1, the family table will have 1, 5, 4, 5 and 11. All of the values are going to be in the family because this is the parent, all are child. For 5 is the parent, right? 5 is going to be in the family and then other children which are 5, 4 and 11. So for 5, it will be 5, 5, 4 and 11. This is the family. For 4, the family is 4 and 11, right? So it is 4, 11. For 11, the family is 11. And for this particular 5, the family is 5. Now, if we are selecting two nodes, 4 and 5, to remove the edges from its parent, so we can see that in this 4, we don't have a 5. We don't have this 5 as a family member. And in this 5, we don't have the 4 as the family member, right? In these two nodes, they are not family of each other. It means they are not connected. I can just use this formula directly, right? Find the XOR of this, and for the XOR of the other table, take the XOR with the total and the XOR of other two trees. But what if they are connected? What if this was the scenario? Because we are right now choosing the node 5 and node 5. We are saying that disconnect it from the parent. So I can see that they are family members of each other. This 5 is having this 5 as its family, right? So I can see that this 5 is having this 5 as its family because in this particular subtree, we have 5 as the parent and this as the child. Although in this particular tree, this is not considered the family member. That is because right now this is the parent and it doesn't have any child. For this particular 5, just in the family, it has just one element which is 5 itself. But if they are family member of each other, now the scenario is different. One of the subtree which is not having anyone as its family, that subtree value can directly be taken from the sub XOR value, and that is because if this particular node is not having the other node in its family, it means all the down nodes can directly be taken without considering this particular node or this particular edge. So I can directly find the XOR value of this subtree from the sub XOR table. To find the XOR of my second tree, what I have to do is I have to say what is the XOR of this whole subtree which is there from the sub XOR table, and then remove this element 5 from that. The XOR of this particular subtree will be 5, 4, 11 and 5. We are going to remove the XOR of the other node, and that is going to be the XOR of my remaining tree. And again, if I have the XOR of this tree, then I can find the XOR of this. How? Take the total. In the total, remove the XOR of this tree, which is 5, 4 and 11. Remove 5, 4 and 11. Take the XOR of the other tree, which is 5. So remove 5. It is going to give me the XOR of my other tree. Again, this is very, very complex, I would say, guys. So even though if you don't understand this in the first go, that is completely fine. Let me try to show you the solution of this problem, and then maybe you can just give some more time to this particular problem and the solution approach as well. Then 100% you will be able to understand it. So now let me go back to the code editor and let me try to show you the solution of this problem using Python. So first of all, we are going to store the number of nodes we are going to have, and for each node, we are going to store the XOR values of its subtree. So we have created a sub XOR table which is having n number of elements as a list. Each element as of now has the XOR value as 0. Then let us create the family list of each of the node. So for each of the node, as of now there is a set which is empty. We are going to update the set. Then we are going to create a graph which is basically a default dictionary. For each of my node, I will try to find out what are the different edges it is connected to. So we can say create a default dictionary and the value will be a list. Then run a loop in the edges, and we can say graph of u dot append v and graph of v dot append u. That is because the tree is undirected. So the nodes are interconnected with each other. Now we have a function DFS XOR, which is going to complete the sub XOR table for each of the node. What we will do is we will call this function with the node number 0, that is the first node at index 0, and its parent is -1. It doesn't have a parent. So index is 0, then the parent is -1, that is no parent. Then we are going to say for the current index, the sub XOR value is the number itself, the node itself, that is nums of index. Then we are going to say for the current node, we are going to update the family. We are going to add the current element itself, the current node index itself as one of the family member. And then we are going to run a loop in its neighbors, that is for whatever nodes it is connected to. And if the neighbor is not the parent, because the tree is undirected, so we may try to reach to the parent again. So this is going to create a circular loop. So we are going to say if the neighbor is not the parent, then run the DFS again with the neighbor and the index being the parent. After you come out of this particular DFS recursion, you are going to say I will be updating the sub XOR value at the current index, which is actually equal to the XOR equal to sub XOR of the neighbor. That is, if you try to find out for 1, initially it will be 1. Then we are again going to run DFS function, and we are going to have another edge here, right? And then we are going to say since 1 is having the next neighbor as 5, what will be the value at 5? So for 5, the XOR will be 5 XOR 5 XOR 4 XOR 11. Then we are going to take the whole XOR value with 1 as well, right? And that will be the XOR value at 1. So we are trying to create the answer from bottom up, right? So we are going to say sub XOR at my current index will be equal to sub XOR at my current index with XOR of sub XOR of at current index and sub XOR of the neighbor. Then we are going to update the family members at the current index as well. We are going to say all the family members of my neighbor, that is my lower node, will also be the family member of the current node. Once the table sub XOR and family is updated, what we are going to do is we are going to say the total XOR will be the sub XOR at index number 0. That is the parent, the whole tree's parent will have the XOR values for all the nodes. That will be the total XOR. Then let us create the result, which is as of now infinite. Now let us run the loop for different pair of nodes. We are going to start from the first node because the node number 0, that is the node with index 0, is not going to have any parent, right? So we are going to start from the first node. Then the second node for the pair will be coming from the next nodes. So for I in the range of 1 to n and for j in the range of I plus 1 to n. Then you are going to find out the XORs from the sub XOR table from both the nodes, right? And then you are going to check that if any of the node belongs to the family of the other node, that is, if they are interrelated with each other, then whoever is the part of the family, that will have its own tree. So the first tree is going to have the value as xj, which is equal to the sub XOR for j. Then the second tree is going to have the value as xi xj, that is the sub XOR value for the ith node, and take the XOR again with the xj. And the third tree XOR will be the total XOR value, taking the XOR with sub XOR of the ith node. Basically the ith node is that node which is having j in its family, right? That is because if I go back to the tab, you will notice here that if you want to find out the XOR of this after you have disconnected these particular trees, that is now you have 1, 2 and 3 trees. If you want to find out the XOR of this particular tree, then you will have to find out the XOR of the total, taking the XOR with the XOR of 5, sub XOR of 5, that is 5, 4, 5, 11, 5, 4, 5, 11 will be eliminated. You will be left with 1. So this is how you find the value for the third tree. And similarly, if j is not in the family but I is in the family of j, then you are going to do the same thing. But this time the first tree will be x of I, second tree will be x of j with XOR of x of I, that is the opposite of what we did here. And the third tree will be total XOR, taking the XOR with the x of j. If they are not in the family member of each other, then the first tree will be the XOR of I, the second tree will be the XOR of j, and the third tree will be the total XOR taken with xi and xj both. Because now both the lower trees are disconnected, so we have to remove the XOR of both the trees. And then finally the result will be the minimum of the current result and the difference of max value of FST and the min value of FST. FST means the first tree, second tree and third tree. Finally, you are going to return the result, and that is going to be the output for this particular input for this particular problem. Let me show you the complete code for this particular problem. You can just pause the video and understand the code itself. Now you can submit this, and this is going to pass all the test cases. And this particular solution is a very efficient solution for this particular problem. You can see that runtime is good, memory use is good as well. So we have solved this particular problem. And guys, I know that this was very hard to understand. Even from the explanation point of view, it is very hard to explain as well. So I hope if you understood something or everything from this video, then make sure that you do hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this video, guys.